All right, well, let's see. We're about ready to get started here. It's after 6:30, and I'll say good evening to everyone. This is the Deep Space Exploration Society engineering meeting for February the 9th. And I'll say hello to Don Latham. Hey, Don. And Rick, you're looking good tonight. Rick K0GD. Mr. Man's always on time. He's got the best time in the world. And Bill Miller and Derek from Teller County. Very good. And there's Dave, AA0RS and AA0RS twice. So good to see you, Dave. And Martha, good evening. And Adrian. And we got Larry from Chicago. How's Larry doing? You want to unmute?
Thanks, Paul. I'm staying warm. I'm also eating dinner, so that's why I have my camera
Oh,
turned
that's
on.
okay. But you're how are you getting on? You getting a little healthier?
I am. Thanks for asking. Yeah, the doctor is going to free me for travel in 2 weeks. So for
Excellent.
the I should be available and on site if there's a need for me to be on site for the next launch window.
You're always welcome, of course, and we will definitely use you because we need good people to manage the dish. And Roger, as usual, good evening. And Floyd, good to see you on. You connected earlier. I guess he's still connecting to his audio. And we got AC0XU. I should know that call sign. Gotta, my brain is not working too well tonight. He's trying to connect his audio. I know that. I know. Anybody know his name? Oh, damn. Uh, Maybe that's um, is that Bruce, maybe, or Patrick. We got Fred. Good evening. And we have AE0OQ Armstead. Thank you for joining.
AC0UX is Scott Resnick.
Scott. Okay. That's XU actually, not UX.
Oh, whoops, XU. So it's not him. Yep, sorry. Typo on my part.
It's all right. And we have Barry. Hey, how you doing, Barry? How are things out there?
Real good, thank you. I'm out in Seattle, so most of the town is still hungover.
Well, good to I bet. Good to see you, and congratulations on the win.
Thank
And
you.
let's see who else we got on here. I hope we don't miss anybody here. We got Alex from Phoenix. We got Vlad from see San Diego, maybe.
No, Laguna Hills, I between San Diego and Los Angeles. Good evening.
Okay, good evening, Vlad. Jeff, good evening, Jeff Fledden. And there's Megan. I guess that's Megan from Haswell. I'm sorry, from Eads. My apologies. And we see Chuck and Zero NHJ and someone called MFB. I don't quite know that name, but maybe if you could give us your name, we can recognize you if you're able to, if you have mic capability there. Okay, but I think, and then we also have Chuck from Glenwood Springs. That's right. And James W7TXT. Yes, sir. Very good to see you there, James. All right, we got quite a crowd tonight. I guess we'll get started here. Let me see if I can make the slideshow work. First, I got to get it working here. Let's see, slideshow. Get rid of this screen. And okay, let's see if I can share this. All right, so this is our engineering meeting for February the 9th. And the agenda is as follows. I'm going to talk about the trip report Saturday. That was just last Saturday and the 7th in Haswell. We have also there's some planned radio telescope testing, which is scheduled for this coming weekend, February the 14th and 15th at Haswell. There's also at the same time a DSES Swap Fest. And we just talked about that briefly, but we have a couple of tables there. And then we have an Artemis 2 update. It's also a new launch date. And we have a little talk about some DSES outreach that we've been working on for the last month and a half to firm up, and it's finally set, so we can talk about it. But anyways, so let's talk about the Haswell trip first. The purpose of the trip on last Saturday was to raise additional 3 sections of 45G tower and the topper, which is about a 1-foot section with a flat top on it and a thrust bearing. And this is going to go on the east tower of the building at our Haswell location. There's also one at the west side of the building, but we haven't started to work on that. Both areas have base sections and concrete already poured when we put the floor cement down for the building. So we did everything at once. The team was Bill Thomas, Dave Wilson, who's also on the call, Bob Henderson, and myself. If you have any questions, just jump in. So let me just give you some, I think pictures are better. So this is us at the site. Then we have Dave Wilson's on the tower, and that's Bob at the bottom. And we have a mast on the ground, as well as another gin pole over here. But at this point, Dave is putting his gin pole up onto the tower here in a second. One thing we found out about the tower sections was before we put them on the top of the tower, we wanted to make sure that they were lined up. And here's Dave basically trying to straighten out some of the legs on the tower, and the ends of the tower were not straight either. So we had to do some remedial work on them and put these sections together on the ground so that we knew that they were going to fit together. So that was a smart idea. The next section was we put the mast into the tower. So the tower sections we had was like half a section, which is into cement. And then we have one section above it, which was done, I guess, maybe 6 months ago. And so we put the mast in, only to find out the mast is actually longer than the tower sections. So the next step we did was we actually didn't need the whole 20 feet. So we shortened it down to 15 feet of mast. So it would not stick out the top when we try to put the next section of tower on. The
Paul, are you saying mast or gin pole?
mast, you know, the mast that holds the antennas. We put that in the tower before we put the sections on the tower.
Oh, I see what, well, okay.
You know,
I see what you're saying. Sure.
it's a little easier than trying to do it into the thrust bearing at the top, so to speak.
Good point. Good point. Yes.
But you know, we were just a little too early, so we ended up having to cut some of it. Anyway, best laid plans, eh? So here's me lifting this whole 100-pound mat. Not really. This is Bob pulling on the rope here, and Dave's helping to lift up the one section of tower that we had prepped up for this thing. And these things are heavy. They're not like 25G. Man, 25G is so easy compared to that. But anyway, so here's Dave wielding this monstrosity around while Bob and I were pulling on the rope to try to keep it up in the air here so that it wouldn't fall on top of us. And let's see. Next one here. See if this will work. Okay, and this is the second section finally in place. This took at least an hour and a half or more with Dave standing on the tower, and that was really, really hard. These sections wouldn't fit together very well here. Even well, one thing we couldn't do was check this bottom section properly, so we were able to get the whole thing down, but we ran out of sunlight, and that was kind of the end of the day there. We didn't try to put the other two sections on because it was just going to be too dark for us to work in. That would not be very safe. So next steps. All right, we got to finish the next two sections and put the topper on. We know that these two sections and the section we put up fit together because we did that on the ground. We're going to attach some guy wires that are there, or I'm not sure if they're there, but they're going to be there. And we're going to schedule this for Thursday, February the 12th. That's Thursday this week at the Dish site. So that's our plan. And if right now we've got Dave and Bruce Kirkpatrick coming down, and myself, and if anybody else wants to join us and help hold a rope or get this or get that, you're welcome to come on down and join us. We'd love to have some more people helping out. Anyway, that was my last slide for that section. So let me go back to the original. If I can find the original here.
Paul, you mentioned guy wires. What's the
Yes.
plan with the guy wires? This is supposed to be a freestanding tower.
Yes, well, somebody made the decision that we're going to put a step IR antenna on there as well as the 6-meter beam. So it may be wise if we had at least one set of guys on the tower. We'll look at that once we get the tower all the way up. Do you have any suggestions, Bill?
Just that it was supposed to be a freestanding tower. The guy wires made it more difficult to move antennas in and out, and so that's one of the reasons that we designed it the way we did.
Yeah, we can still put the antennas on. I mean, the tower is probably very strong enough to hold the antennas going up the side. But once everything is in place, it may be a little bit safer to put at least one set of guys on there just to keep it in case we get one of those 60-mile-an-hour winds or something. But anyway,
It will be wise to have anchors for guide wires, set up antennas, and set up guide wires after that. So
yeah, that's the plan, to put the guy wires on after the antennas are up, and the mast and the rotator and all that stuff is in place.
Okay.
Anyway, what was I doing here? Let's see, going back here to the agenda. So the next thing on the agenda tonight is the plans DSES 60-foot radio telescope testing. And that's going to be done this coming weekend. And perhaps if Alex, are you going to talk to this a little bit?
All right. Well, I'm coming down again.
Again, yes.
Yeah, apparently Haswell missed me. So just for one day this time, unfortunately I can come on Friday, so I'll be on Saturday and Friday. I'm sorry, Sunday. And Roger gonna come as well, I believe. So we're gonna work on the feed because we need to get the Artemis 2 stuff going based on the previous testing last weekend, the weekend before. Initial tests showed that we have some lack of gain, and there are a few questions raised. One is we don't have any recorded data of the dish performance other than we have for the pulsars and just basic measurements. So we decided to start documenting everything and make sure we document every single frequency we used, band we used, and performance. Like at 80 gigahertz we had pretty good success, and then on S-band 2.2 wasn't that success, so kind of made us believe that we need to do some measurements. So plan is I apparently when I did simulation here, the feed that we use and all feeds we have for 2 gigahertz are not quite optimized for our FD ratio for our dish. So we know what the FD ratio is. So there's a certain radiation angle that the feed should provide in order to keep the efficiency, eliminate the entire dish surface. The lack of gain comes from the incorrect radiation pattern. So basically, over eliminating and losing a lot of gain. So I designed 2 things. One is a scalar ring already built, and the second one is a flare. Both goes on the existing feeds we have, DSES as well, and we're going to test each of them to prove that to improve the performance on S-band. That will answer the long time question: what's up the dish and how's the dish perform on S-band? So in parallel with that, we'll do some measurements on the dish surface itself. So let me show the dish still has a proper surface geometry. Over 70 years, there was no deformation of any kind occurred over years. So we're going to use two methods. One is the optical method, and the second one is just simply measuring the surface curve of the parabola. So those measurements should be done on Saturday. So we have collect that data and we document that, so we have it. And on Sunday, we're going to start working on the feed improvement and the beacon test. Perhaps this time we're going to do two positions, due south and due west. So collect data from both directions, also document that. Unlike previous times we use SDR software, this time we're going to use a professional spectrum analyzer. So we're going to collect the actual data directly from the feed to bypass all front end stuff. We will again document all of those measurements and decide what next step's going to be. So that's the plan for upcoming weekend. And then we're probably going to have an additional meeting after the results. That's what I had.
Alex, I just want to confirm, whoops, echo, that we're not using that preamp. I don't know why I'm getting an echo. Here, I will. There we go. Okay. I just want to confirm that we're not using that unit that is the preamp, filter, splitter, and additional preamp, correct? Yep, you have to unmute.
Sorry. Yeah, well, we'll eventually use that because that's the final configuration. For the test that we're going to conduct, we don't need that. But
yeah, I was just speaking to the test.
Yeah, for the test, we don't need that. But in end of the test, everything I described, I'd like to use that assembly in the existing Artemis system to try to detect the S-band probes. So that will determine that. But plan on attaching it at the end of the test.
All right.
Okay, any others? Sorry, I had to take a drink. All right.
The weather doesn't look terrifically good.
Why do you say that?
Different weather apps, different reports, I suppose, but looks like it's going to be some precipitation on Friday and Saturday.
I was looking at that. Supposed to start after sunset on Friday and end sometime around 5 a.m. In the morning. This is all it has. Well, I don't know what it's like in Denver, but it's going to be it should be okay for the day. It might be depends how fast the ground dries and how much rain we get it. They're not looking for a lot of it, although we could sure use it. Ground is very, very dry at the moment.
Yeah. And I don't know if that would have anything to do with the testing that Alex is talking about, but it might mess with you guys working on the tower.
Yeah, we're going to do that on Thursday.
Thursday, okay, got it.
Yeah, that was the plan.
Well, I definitely don't want to have a rain, but once again, I can undo. I have to at least bring the stuff. Second, we'll at least to try to do something, because we can't afford to lose the time. And I'd like to check everything before Artemis, and not to wait until the last minute, right? So that's why I'm using all these opportunities. But if it's weather won't cooperate, well, we can't go against it. We'll go. We'll play.
Thank you. It'll be, I'm sure it'll be great. And it's supposed to be sunny on Saturday, so it will be warm.
Paul, I was going to mention
Sure.
that if you wanted to do the mirrors test to check the dish,
Yeah.
you have the tower on the trailer already erected that's probably tall enough to do a light source to do the mirrors test. And so if you wanted to do that instead of spending all the time with the crew working on the tower, you could go there.
Yeah, I understand. The only thing that concerned me about that tower is it's not 25G, it's 20G, I believe. In other words, it's narrower. It's the
Yeah.
same kind of tower as we have down by the bunker, and it's only supported about 5 feet off the ground with a bracket that's attached to the trailer.
Yeah.
And,
Both Roger and Ray have been up that tower.
yeah, I'm not ready to do that.
But you see what I'm saying? I mean,
No, I understand.
You could use the crew to do more important work on the dish and forego the tower for now, the 45G tower for now, and that would save you a day.
It's not the same people.
Could be.
Well, I don't think so, because it's going to be Dave AA0RS, myself, and Bruce doing the tower work, and it's going to be me, Alex, um, and Roger doing the dish
Okay,
stuff.
I'll let it go. Just a suggestion.
No, it's good. You're not the first person to suggest it either.
Paul, since we have, I mean, you're going to be there on Thursday. I'm going to be there on Saturday. So
Right.
I'm assuming you're staying all these 4 days there, correct?
Negative. No, I'll be heading back probably Thursday night, and I'll pick you up Saturday morning at the airport.
Okay. All right. So because we have only Saturday night, I'd like to have that source available on that night. So when we arrive, the first thing we're going to do, well, 3 of us, unless if someone's going to join us to volunteer, so we can split in, depending on how many people we have, we can split into two teams. One team going to be working on the dish itself, surface. The second team going to be installing the light source, and it doesn't really matter. I mean, we can use that tower that Bill suggested. You don't need to climb. I mean, you can attach the light source to the pole and attach the pole to the tower. All we need to have 8-meter height. That's exactly the height of the feet. So we have to be on the focal point. Light going to be pretty broad, so I'm not really care how accurate it's going to be. But if you have 5 feet plus additional 10, 15 feet, that's all the height we need. So think about how we can attach without spending a lot of time before dawn, before gets dark on Saturday. So we can conduct optical test and the dish measurements on Saturday, and on Sunday morning, hopefully the weather going to be good. Then we're going to work only me and Roger on the feed itself. That's going to take majority of a day. My flight is at 10 p.m. Sunday, so we'll have plenty of time. Now, really, it will depend on you how late you can stay to take me back to the airport.
Yep, not a problem.
Hey,
go ahead,
guys. Paul, what form does the light source take? Is it a square box with a incandescent lamp in it, or is it LEDs or something?
So I've got I actually have I needed to get a flashlight anyway, so I bought a LED flashlight which has got like 9,000 looms, and it will be great. We can mount it on a tower and tape it on to the tower pointing at the feed. I was under the impression that the light had to be about the same, when the dish is at horizontal, that it would be going straight into the right into the focal point into the back of the hub. But Alex said you just said it's only be 24 feet off the ground.
8 meters.
8 meters.
That's the height of the feed at 0.5 degrees.
Well, anyway, the gin pole that's up there, my gin pole, has got a rope. It's got a rope on a pulley, so you could attach the light source to that and just tie it off at the right height.
Correct, and that's what we'll do.
Because if I come down there and put the other two sections on, then there'll be no gin pole or anything, and you'll have to climb up the tower unless we put a rope and a pulley on there for you.
We still have the old gin pole, and we also have there's some rope in the base of the tower. It's fairly thick rope, but we could look at that if you want to. I mean, you still have to go down and get your gin pole, right?
Yeah, I can come down some other time, but whatever way you do it, if it's not fixed on the tower, it's going to flop around if there's any wind.
Of course, yeah.
Yeah.
That's why it has to be secured.
Yeah.
Anyway, I'm pretty sure we can do that. And right now, Dave, you can, if you want, you can pick up Bruce, because he's on the way down from your place. He's in he's in Henderson.
Yep, I'll organize that with Bruce and contact him.
Perfect. Okay. So
I'm a little confused.
I don't mind driving back.
Oops, sorry.
Go ahead.
I thought the height of the feed at a zero elevation is about 11.5 meters.
Yeah.
Because the dish has a 30-foot radius, and I'm going to guesstimate that it's about 8 feet above the ground. You can reach up and touch it, but it's closer to 11 meters up.
So last time we measured when we were doing beacon test, the first one, if you remember. So the base of a dish is at 1310 meters, and at the feet is 1318. So it's exactly 8 meters. And I verified last time as well with the GPS readings. But what we can do is we can drop the tape measure, right? Or rope, whatever, and we can verify that. So I wouldn't worry about this right now, but we need to be exact, so let's verify that.
Yeah, Bill Miller, how tall is the scaffold?
Well, the scaffold's 35 feet to the platform. The dish is 5 feet off the ground, and half of the dish from the pivot point is 30 feet. So I'll go back to feet. Sorry, Alex. It's 35 feet to the center of the dish off the ground. And the scaffold is essentially a little less than that, since you're standing on the scaffold holding on to the hub.
It turns out about 10 meters, 50 centimeters.
Yeah. So if you don't include the elevation that Alex included in his calculation, you need about 35 feet or 10.5 meters. If you include it to go off towards the tower at a 5-degree angle, then it increases over that angle and the distance to the tower.
Mm-hmm.
Yep. Okay. Well, anyway.
So my suggestion is make it simple. The more engineering projects you involve in this exercise, like putting up additional tower sections, the longer it's going to take. It took you a day to put up one tower section, and I understand the complexity of that. But if you want to get this done, make it simple.
Okay. Well, worst case is we don't get it all done. We just use the tower that's attached to the trailer. But
Yep.
Either way, we're going down on Thursday, and we're going to do whatever we can. And I'll be back in Denver on Thursday night, so
Okay.
I'll be down there on Saturday and Sunday as well. If anybody else wants to join, we're there.
And you don't have the mirrors, right? Alex has the mirrors.
Correct.
So if you had the mirror, if you had the mirrors, you could actually install the mirrors on, if you didn't have this other work to do.
No, I can't go on the dish.
No, Bill, I'll install mirrors. It's fine. I just need a helper. It should be easy. I have 400 1-inch diameter mirrors. Because we're gonna be doing. I need one helper at least on a dish, probably Roger, to do two things: install the mirrors and do tape measurements of the parabola shape. I need to take multiple points. So that all should be done on Saturday. But we do have a tower when over the bunker, right? And we can use a worst case light source there. If we do have LED, that should be enough.
Well, you have the tower on the communication trailer that is tall enough.
Yeah, I mean, I've never been on that tower, but yeah, you're right. I mean, if a thing is tall enough, it's the one that has to be element Yagi on it.
Yep.
Yeah, and you said Roger been on there on top.
Yep.
All right. Well, that's gonna be plan A then.
Okay. Very good. Okay, so that is the testing of what we're going to be doing. By the way, you wouldn't want to put anything on the tower or on the dish Friday or anything before Saturday because we're going to be expecting rain Friday night into the next day, and I'm not sure how well those mirrors will hang onto the surface if it gets wet.
And also another third method I forgot to mention. I'm gonna bring my DSLR camera, Canon, and there is another method to take pictures. There's a special program you can actually take all these pictures, upload, and it will create the parabolic shape and calculate everything optically. So I'll take that camera. That's going to be a third method. The camera needs to be installed somewhere on the feed that we can take a picture from the feed in all directions and overlap them. So that shouldn't take more than probably 20 minutes. So it's going to be 3 methods on Saturday then.
That'd be awesome. Thank you. Alrighty. So moving on. So the next item on the agenda, I think we're still sharing. Or no, we're not sharing. Hang on. There we go. So the next item on the agenda is the Swap Fest. That's going to be held at the Adams County Fairgrounds. That's sponsored by the Rocky Mountain Hams Group, and they usually have a pretty good ham fest or Swap Fest as they call it. And we have 2 tables there, and we Derek and what am I trying to say? Derek and Bruce are going to be manning those tables since I will be down in Haswell on Sunday. So and Bill Thomas is out of town this weekend. So that's going to be the plan. If anybody wants to join us down there, we're more than happy to see you on Sunday the 15th, and we'll get some pictures from down there. All right. Any questions? Okie doke. Next item is the Artemis 2 update. And we also have a new launch date, and that's going to be in March, probably around the 8th and 9th, I believe. And Glenn, you had some stuff that you were working on, some information regarding tracking. So would you like to give us some of that information now?
Certainly. Let me share the screen after you get done with it, I guess. Haven't done this in a while, so this might take a second. And let's see. Okay, can you see that at all?
Yep.
Okay, great.
Looks good.
So what I have done is I put together about 5 slides somewhere in there to discuss where we're at with the manual pointing tool that we were creating. And just for a quick update, we came on to this project latter part of January, and we were asked to come up with some method to allow us to point the dish at Artemis 2 on its way to the moon. And we came up with 2 plans. One was one that we could get done relatively quick and make it manual, but make it smart enough that the operator can do it relatively easy. And then the second one I'll talk about at the end. So let me go make this bigger. Okay, so the first one is the System 1 ephemeris tool, and this is a manual tool that'll be used to give the operator cues as to when he should enter a command. So this manual commanding the telescope will require the JPL Horizons tool, which I think a lot of folks have seen now. The System 1 ephemeris tool is the tool that I'm going to talk about. And then the System 1 mount control software is the software you guys have seen, for the last several years. Phil Gage is working on the System 1 ephemeris tool, and I'll show you the display here in just a second. And we really hope to have it completed and tested by sometime by the end of February. So this is a manual tool to make it easier for the operators to point in the right place. So let me bring up the next couple of charts, and I'll demonstrate how each of these tools will be used. So this next display is the Horizons Web Application tool. And basically what you do with this tool is it's online and it talks to the JPL site. And you can go in and you can edit these different things, such as target body. In the future, we're hoping this will be Artemis 2 when they actually get a vector in there. Observer location should be set. This is Haswell. The time specification is based on maybe an Excel spreadsheet or maybe other work. We'll have a pass time. And based on that pass time, we would update these start and stop times. And then we have these other custom settings that generates the data that's required for our tool. So let me read to you what I got down here at the bottom. I said the operator will use this tool to generate the ephemeris file called horizons_results.txt at the desired half step rate. So right here, there's this step. Lewis has been doing some calculations to see what will be the minimum time we can wait between commands. So let's say the Horizon Engine declination for Artemis is changing such that we only really need to issue a command every 90 minutes. Well, the step will generate steps that are in between. So we'll get the 90-minute and the 45-minute steps. That way, that data will go into the file that the next tool will use. So the Horizon results.txt file will be used by the System 1 ephemeris tool to allow the operator to position and track the Artemis spacecraft. So this is the standalone tool that Phil's working on right now. And what you see is a list of command times, and Horizon Engine declinations. So the operator can bring up this tool. It'll use that other text file to create this data that you see in this window. Down at the bottom, you'll see several fields. The first one here is the time until this command needs to be executed. So that command consists of a right ascension position of 202.26, blah, 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 and a declination of -7.59183. So this is where the mount needs to be at this time, or relatively close to this time. So what the operator can do is select this right ascension and this declination, and then I'll go to the next chart. The System 1 software has this converter tool built into it. So what the operator will do with this is he'll cut and paste the right ascension and the declination. Now, unfortunately, if you look at how the System 1 software works, you have to have these fields to actually execute the command. So if you put these in here and you hit this convert button, these get generated automatically for the operator. The operator can then do a copy right ascension declination and then take this information, and then let me go to the next chart, and do a paste, this paste RA dec, and it puts the values in here. So essentially, what the steps would be, you look at this tool to figure out what you need to do and when you need to do it. You use this tool to convert it to the appropriate output for this tool. You paste it in, Well, actually, what you would do is you would stop the current track, paste it in, and then start the next track. And that would be so quick that we wouldn't really lose tracking at all. So that's kind of how we're looking at as far as the manual tools or the manual tool set that allow us to be able to use the system as it exists today with little to no operator interaction. So let me go back at the beginning. So does anyone have any questions on this?
Yeah,
Maybe
Glenn,
for Roger?
where does this Horizons web application information come from?
It exists on the web, and you have to go to sdd.nasa.jpl something. So there's a website for it, and brings this up automatically. Now our goal is to sometime by the end of the month give some operator interaction or some operator instructions as to how this tool can be used to create this Horizons results.txt file. So that would be on the web. So quite honestly, all this stuff depends on having the web because we won't have any pointing information if we don't have the web. So this data will be good because this is the area that NASA will be putting into pointing vectors for the Artemis 2 as it proceeds over time. So this will give us accurate data.
Glenn,
So
Roger here.
Yes, sir.
Do you have any idea how long after launch this will be populated?
The way Lewis went back and looked at the Artemis 1 data, and he seemed to think that it was relatively quick after the TLI. So within maybe 30 or 40 minutes after TLI. So we're kind of, the translunar injection point of the orbit. So we're kind of at the mercy of NASA to getting that data into the JPL Horizons tool. And then of course, as they do maybe mid-course, correction burns or other things, they will go back in and update those pointing vectors such that when we go back and we get ready to do a pass, everything should be updated. I'm sure they'll do it offline. Should be updated. We should be able to run the tools, and we should be able to track appropriately.
So let me direct this to Rick Hambley. Rick, as our point of contact, could you contact NASA and see if they're planning to populate this site fairly quickly after launch, since we're dependent upon it? I don't know how other people are getting ephemeris data.
Well, what's been described so far is based on the information we already got from NASA on this question.
That's correct.
Okay. All right.
Let me bring something up just real quick, Roger.
Sure.
I'm gonna stop sharing just for a moment. If I can find it.
Are you going to show those charts you showed me?
Yeah.
Okay. Yeah, those are good.
Okay, that is if I can find them. I had them up earlier.
While you're looking for that, Glenn, I'm going to ask a question of Roger. I think Roger knows this.
42.
Say they launch, how much time are we in Earth orbit before they go TLI?
About 23 hours.
23 hours. So that's a number of orbits because they're orbiting at like 90.
No, it's actually one very eccentric orbit.
I see. Okay, so it's, as I understand it, I thought it was one regular orbit and then one very eccentric orbit. And then they do TLI.
Though I'm not 100% sure, it appears that they launch and then they immediately boost into that highly eccentric orbit. And so that orbit is what takes that one orbit is what takes about 23 hours.
Okay.
And then approximately perigee is when they do the TLI burn. And I think it's after the TLI burn, which is our first 8-hour data collection window.
Okay.
And
here's from the time of TLI. Glenn's got it up here.
Yeah. So can you see this chart? Essentially, what you're seeing here is the actual rates. This is the rates, and these are the position data from Artemis 1. And basically, TLI is occurring like right here on the chart. And then these are the actual passes in the future, right here, here, and here from the Haswell site. And these were the dates in 2022 when the data was appropriate. So you can see the rates as they change over time. But the important thing is on this chart, you can see the rise, ascension, declination positions. And once they get on their way to the moon, they will change gradually over time. And because they change gradually over time, this being a day between each of these, how often you have to stop the mount and recommand it with a new right ascension declination probably will range in values from maybe 10 minutes over here to maybe 90 minutes through here. So that's what we're seeing right now. Lewis is still looking at that data, but that's kind of what we're looking at. So let me go back to the other chart. Find it. Okay, can everybody see that okay?
Yes.
Yep.
So what's going to happen is this blue line is just going to go down after one gets executed or after the time goes by. So let's say it's 40 or it's 90 minutes before you issue the next one. This will be 90 minutes 00 and it will start counting down. And then this will be populated with the appropriate command. So once this gets down close to 0, then the operator, what he'll want to do is he'll want to cut and paste this out into here, hit convert, then do copy, go to this one, stop the track, paste it, and then start the track. And that's the entire sequence for doing a commanding of the mount, manually.
Good.
So
That's only a stop of 10 seconds. That's good.
no, it's probably more like 1 or 2 seconds, maybe 5 seconds.
I'm being pessimistic.
Oh, okay. That's fine.
Hey, Glenn, I have a
Yes, sir.
question, Alex here.
Uh-huh.
So we anticipate the beam width of antenna is 0.5 degrees.
Mm-hmm.
So looking at this right ascension declination, what do you think the difference? Is that more than 0.5 degree? In other words, if it's flying away, we don't have fresh data available, and we cross 0.5 degree point, we're going to lose the signal. That's what anticipated from the RF performance.
Right.
So can you somehow correlate from Artemis 1 and just using 0.5 degree tolerance? That's at minus 3 dB, half power beam width. That's what we're supposed to get. Previous tests, it shows about 0.6 degree or so, but with the new flare, it's going to be about 0.5 what is anticipated. Just FYI, if we're going to be outside of 0.5 degrees, this signal is going to be dramatically falling down.
So let me address that. First of all, Lewis, I think, has already done the calculations. So, but he's out of town, and so I didn't really want to put it up because I didn't know exactly how to explain it. He certainly can explain it much better. So why don't we plan on having a meeting when he gets back into town next week, if that would be okay? And we can talk through that.
Sure, yeah, absolutely.
But I think he's already done that work as far as what you're asking, but he would be the better person to ask than me.
Perfect. Just want to make sure we're on the same page. All right, thank you.
Glenn, another question here. So it sounds to me like your first step generates a text file, which this program we're looking at right now. No, sorry.
That program.
Yeah, okay, so this generates a text file, which is what's the input to the next program?
Oh, this generates a text file. The actual Horizon website will generate a text file.
So will there be new data published if there are any course correction burns?
Yes, there will be. And what we believe will happen is NASA will post those changes on the website, which will change the ephemeris that this website uses to generate the rise ascension and declination positions. Now,
Okay, and then you have to then fetch the new text file and populate it so the next tool gets it. Okay.
That is correct. So down the road, Roger, our plan is obviously to take some maybe slides like this and then maybe have a train the trainer kind of thing and talk about how to do it.
Okay.
Does that sound reasonable?
Yeah, and let me just throw out something I've been thinking about is, I think that the only way that this is really going to work well is, we have our volunteers, but what are there, like 8 there are about 8 data collection periods, give or take. And I really think that probably the board and or the people that are really contributing to this, probably we're going to have to split that up so someone knowledgeable is down there. And but what's the great thing is that we can train the folks that have volunteered, and they can
Yeah.
kind of handle it while we go off and work on other stuff that needs to be done down there as well, and or get them started and then be able to leave. But
And
I think we're going to need someone there that's knowledgeable to begin with.
my plan is honestly is to be there on at least the first day where we will probably get good data from this website. And I'd like to
Hmm.
be there and then make sure that we're doing everything correctly for that first pass. And either stay a day or maybe 2 days and try to work with everybody as we go along.
Yeah, you, me, and everybody else. I was planning to be there
Right.
immediately.
So,
I figure we've got 23 hours to get down there.
right. That's about
23
right.
hours warning.
Right. So let me go on to my last slide and then I'll stop talking. And please forgive my drawings. All right. This is my design diagram. So what I am doing in the background versus what Phil and Lewis are doing is Phil and Lewis were trying to get something put together rapidly. So if we had to go in February, we'd have this tool and some of this other stuff so we could actually do this manual pointing. Now, what I'm working on in parallel with the other tool is an actual update to the System 1 software where we do automatic object tracking. So in other words, instead of having to use all these manual tools, you'll just do a selection on, let's say this is, how you could select Venus, or you could select the moon, or you could put right ascension declination. I'm going to add this JPL Horizons selection. And what it will do is it'll put up a new display, and whatever's in this horizons.property file, which is a keyed file where you have a name and the JPL object ID, we can put this list up, and then the operator can select Artemis 2 and say go, and it starts tracking. And then it just continues to track. The operator has no interaction with it until he says stop and he wants to select something else. So this is an automated version of the other stuff that you just saw. Now, what this software does is it basically uses the JPL Horizons website as a propagator. And via the JPL Horizon API, you can query the database online and get the pointing data that is required to actually create the position data and actually point the mount. So this is where I'm heading. Unfortunately, for me to do this, I'm going to need some help from Phil. So I'm not sure what I'm thinking is if it slips again in March, we will definitely have this type of processing by April. I think I can make March. I'm sorry. Did you say something?
Alex is unmuted.
Oh, I'm sorry.
No, I just was going to say, Glenn, that's amazing, because this is exactly what we need for the Eve 26 and for DSN. So that's definitely going to be super helpful for all upcoming projects. So appreciate your time working on this.
So if you take a look at this file, if the object exists in the Horizons website or in its database, we can put it in this property file, which is just a text file. And I can go in, or you can go in, or whoever's responsible for the file, and we can put in a key valued pair for something. So if you look at the Horizon website today, you'll see that the New Horizon, Voyager 1, Voyager 2, many of the Mars spacecraft have JPL object IDs. So, when we get done with Artemis 2, we can eliminate this and maybe we could add something else in and we can go from there. So we're trying to make it flexible in that point. So kind of what you're saying, Alex.
Yeah, thank you very much. It's very helpful. Appreciate it.
This is where we're heading. And then the other thing I wanted to point out here is there's this thing called maintenance, which I actually got done last year. And this is another thing where if you select it, it'll put it in the maintenance position, which I think is something Roger's been wanting. So So that's kind of where we're at. And I'm going to try to get this done by March. But if I don't get it done by March, we have the first tool. And then by April, we will definitely have this tool up and running.
Glenn,
Okay.
just a comment about your diagram. There's a missing block, I think, which
It
is
could be.
that conversion stage for the location.
Oh, right. That would be another processing block, and this is more of a display block.
Yeah.
So, and quite honestly, I already have that API working, and I've already got Venus working, so I can automatically track Venus via the web. But it's going to take a little more work for me to get this kind of display work done and get that up and tested before the first part of March. So that's where we're at, and I'll give it back to you, Paul.
Very nice.
Super. Thank you very
Glenn.
much.
Thanks, Glenn.
Yep.
Glenn, I added a note, if anybody wants to try and get on the horizons and get information or see what that information looks like, you can type this little bit of code into a command terminal, and you can talk to the Horizons web base.
Certainly. Yeah. So what I've done is I've taken that interface, and what I do is I send a series of parameters to it, like I want it once a second or once a minute, or I want the Julian date and I want a string date, or I want J2000 a rice engine declination, but a parent as L. There's just a million things you can do with the tool, and it is very useful. Okay. Thanks, guys.
Thank you so much. I really appreciate you taking the time to pull all that together and the work that you and your team are doing there. It's amazing just to keep this thing going. All righty. Let me go back to share again. So the next thing is so we have the launch is coming up. This is a picture that, see, did I get the right picture? Yeah. This is the photograph that Mark Pruill, he's N9EDK, actually lives in Arvada, near Denver, and he's like one of the head architects of the Artemis 2, or actually the whole Artemis program. And he took this picture for me, which I've shared. So since I met Mark back at the HamCon Colorado, that's the ARRL one, back in October, I was trying to get Mark to agree to come down to Eads, Colorado, or to Kiowa County, which hardly ever gets anybody that's this gifted and this technical to come down and do a presentation like the one he did for us. And we finally firmed it up on Friday of last week that he is able to come down on the 22nd of March. And I was also able to confirm that the Eads Theater, which is called the Plains, is available on Sunday at 1 p.m. So this is another outreach that we're doing. Again, I've been working on it for a while. I've been letting a lot of folks know that we were looking at it, and we finally confirmed it on Friday. So if anybody wants to come down and join us, you're more than welcome to. I'll be down there with Mark. Mark is going to actually come down on Saturday before the event, and he would like to take a good close look at the dish and all the stuff that we're working. But Mark's the principal network architect on the Orion spacecraft program for Lockheed. So he can answer all the questions. We're expecting a theater that's full of kids from all over the county area and probably the adjoining counties to come and see this. So the next weekend, the 29th, is also available as a backup in case of weather problems on the 22nd of March. Hopefully, the Artemis program the launch will be on time, or whatever on time means when you're launching a spacecraft. But hopefully it'll be done by the 22nd, and there'll be lots of interest in it. And this is one of the helpers and one of our members put this one together, and is going to be posting this in various locations down there, so that the local population will know about it. But this would be probably one of the first times something like this has actually happened down there in Kiowa County. Any questions on this?
Do we have to pay anything for the theater
No.
usage?
No, there's no fees, no charges for any of this. This is all no charge. And I offered to drive Mark down. He said, no need. He's honored to do this for the Southeast Colorado people. And I think it's a really great step on in trying to get more science into Southeast Colorado, because they're very underserved when it comes to science, and we're probably the major point of science in Southeast Colorado right now with our building and location and all the people that we have down there. So
your contacts in EADS knows this is happening, and they're advertising this, I hope.
yes, that's correct. This is a flyer. We're going to be contacting the media in the area. Of course, all the radio stations will be picking it up. I'm going to try to see if I can get the TV stations in Colorado to pick it up as well, maybe in the Colorado Springs and the Pueblo area. But we're starting to put together the media plan, and we're welcoming any help from anyone else who wants to join us in putting together the plan. Okie doke. Anything else?
Yeah, I've got one, Paul. We
ahead.
have the Pikes Peak Regional Science Fair on February 28th. Something that we've done for the last 4 or 5 years. And generally DSES sponsors some certificate and cash awards for the top, at least the top 2 science fair projects in both the senior and the junior divisions in this science fair. It's held at the University of Colorado Springs campus, and that'll be the 28th at UCCS at judging starts around 10 a.m. on the 28th, which is a Saturday, I believe. And then we'll probably have the awards. We'll decide on who we pick for our special awards. Usually we pick special awards that have something to do with space or radio or something kind of in our area. There are other special awards for biology experiments and geology experiments and those sorts of things. But for us, we generally focus on the things that we're interested in. And then there'll be an awards ceremony. And but generally, the judging is only from 10 a.m. through about 1 p.m. So that's 3 hours. And I think Roger has already signed up. And I'd like to get anyone else in the Colorado Springs area or even the Denver area that wants to come down to volunteer as a judge. It helps to have about 4 people total to cover the whole fair. So if anybody wants to participate in that, give me a call or send me an email or volunteer online here. Floyd's waving his hands.
You can sign me up.
Okay, Floyd. Good. I got to say that this is a really interesting event. If you've never judged a science fair, I'm always totally amazed. We talked about the younger generation, but let me tell you what, you will be inspired by the younger generation and some of the things they come up with you never would have thought of, and you will go back and crack open the books after you go to this to catch yourself up. So I appreciate it. Anybody who wants to do this.
There's some
Um,
good
um,
eggs. There are some good eggs in that generation out there.
That's absolutely right.
Bill, how many more people do you need, or would you like to get?
Well, I'd like to get a couple more. That'd be great. If we
Sure.
had three per division, there's a junior and there's a senior division, and usually it all depends on the fair. Some years the fair is very large and we can't cover everything, and some years it's not that large. So I think last year it was probably about maybe 40 projects per division. And so we're trying to cover like 80 projects. And some things, you kind of look and you say, yep, that's not in our area. We won't even look at it. Other things you look at and you say, well, that's in our area, but we'll put it on a note that we'll come back to it because it's not overwhelming. But then you'll see projects and you'll say, I really want to look at that. So it's hard to cover it with just a couple people. So yeah, the more people, the better. 6 would be ideal.
I think maybe Bill Thomas was interested when I was discussing it with him, but I'd like to maybe put it onto our group email that we have for members and send that out this. Let's see, I guess it's only a couple of weeks away, so
unfortunately, I'm a little ADD or ADHD.
a lot of letters.
And I get this stuff, and then I say, yeah, I have something to do. Now, what was it? And this is one of those.
Well, thanks for bringing it up. That's really a great project, great thing to do, and I think the more members we have involved with that, the better we are.
And this is part of our educational outreach, is part of our charter too.
Absolutely. Well, I'll make sure we get some publicity on that and get that going so we get some more members to volunteer. Okay. Anything else? Oh, by the way, Bill, you didn't mention we were when you and I were down there. We fixed the water measuring device.
Yeah. Paul's been after me for the water. He always wants to add water, and so I said, don't add water until you know how much we have, because if you overfill the cistern, you can blow out the seals or flood the electronics or whatever and break things. So last year we put in a ultrasonic. I call it an ultrasonic radar, but it's basically a ultrasonic device that pings the water level in the tank and displays that on a 10 or 12 element LED display, and shows you how much water we have in the tank. And I installed that last year, broke a rib doing it while I was leaning over the lip of the manhole to the cistern. And it worked for a while, and then something happened. We probably took a lightning strike or whatever, and it knocked out the sensor. So last week we put my endoscope. I have a endoscope with a 20-foot articulated end on it, and we looked down through the fill pipe into the cistern and said, yeah, that doesn't look like it's very full. So we couldn't tell exactly from the image we got. So we took the lid off, and we were almost exactly at half. So out of 50 inches, we had about 25 inches of water in the tank. And so tested the sensor, discovered it was bad, and I had another one, so we installed it and calibrated it, and now we have a sensor in the building that pushes a switch, and it tells us how much is in the tank. And Paul's last report, it came in at 40%. And what we discovered from that is people use a lot of water. We're down. So we got to get a delivery, and I think Paul's probably already got this set up, but we need another delivery of about 600 gallons of water.
You need an emergency dipstick.
Yeah. Well, I thought that was my endoscope, but that didn't work out too well. Maybe a brighter light source on it would help.
I was going to get like some kind of a float and then put a stick on it, sticking out at the top maybe, and then as the water went down, the stick would go down. But that's too complicated. We had to go with ultrasonics.
Yeah, the ultrasonic is the simplest, cleanest way to do it. Remember, we have to keep this thing sealed, so that we don't knock dirt in it and get bugs in it and all of that. So, yeah.
Yeah, for sure. I didn't see any bugs, but that's a good point. Yeah. Yeah, when you test this thing, just so you know, when you push the button on the wall, it takes almost 45 seconds. It does a lot of up and down and this kind of stuff going on. And finally it stops and shows you how many LEDs you've got. So I'm a guy that's like the bottle or the glass is half full, and you're the guy who says it's half empty. So we're in sync.
Yeah.
Thanks, Bill.
And if you do push the button on the wall, make sure you turn it off after you read it.
That's another good point. Yes. Read the sign.
And oh, by the way, conserve water. We only have 1,200 gallons.
Yeah. Yeah.
Oh, yeah.
Shower with a friend.
Yes. Well, don't do that. That's going too far.
All right. Sorry, guys. Yeah. Okay. I think we've had enough fun tonight. Thank you very much for everything. And if anybody wants any more information about Haswell, or you want to come on down, just get hold of any of the board members. You can send me any.
Just one comment.
Sure, Chuck. Go ahead.
So one thing to think about in my past life, I used to deal with NASA traffic and stuff. One of the things they used to be really firm about was having a hard freeze date before missions. And that's something that we ought to think about a little bit as far as what the drop dead date is, that we're not going to make any software changes. We're not going to make any changes to things that could impact our ability to do like the Artemis mission, and make that a hard and fast rule so that the day before, the night before, or the day of, somebody doesn't say, oh, well, this will just be a minor change and, it shouldn't impact anything. And we end up, down the rabbit hole kind of thing. But just, that's one of those things that I think NASA learned the hard way years and years ago. And, we used to get those notifications of, as of this date, there's no changes. And so that's just something to consider, that maybe folks want to think about, that we have everything set up and done, with a couple days to spare, and, it's hard and fast because, I heard a couple comments like Roger was mentioning, oh, we can go on and do other things while the operators are watching the mission. And we want to make sure that those other things aren't something like, messing with the network switch or wiring, Cat5 cables or any of that sort of stuff.
No, I mean like things like upgrading the scintillation experiment and other non-related stuff. There's plenty of
no, I mean, working on the tower and that sort of stuff would be fine, but it's just one of those things where that ought to be really well delineated so somebody doesn't say, oh, here's one of the things on Bill's list I can do while I'm sitting here killing time, and all of a sudden we've dug a big hole that we have to get out of.
Yeah,
it's
Chuck,
just a one-line change.
Chuck, that is our normal mode, to be down a rabbit hole. So
yeah.
I hear what you're saying, though. Yeah,
good point, Chuck. And I've already in contact with the operations director for the Eastern Slope Technologies people who provide us with the internet, and they're quite aware of what we're going to be doing, and we're going to let them know at least 1 week in advance not to change anything in the network. And they said, yes, we won't change anything until we're done. So,
Paul, I did have one other thing.
Sure, go ahead.
And that's our power outage of yesterday. Yesterday, the power to the site went out at about 9:40 in the morning, and I didn't notice it. Paul sent me a note, said, yeah, the power's out. I didn't notice his note until late in the afternoon. I was in Parker and in a kids event. And so anyway, we called Southeast Colorado Power and told them about it. And they sent somebody out. They were out there by about 6:30. I didn't call them until about 4:30. And they got out there, and whatever they did, they reset the power, and they even came on site to check that our meter was working on site and that we had power restored. In that process, our cameras went out, and one of them didn't come back up. One in the bunker didn't come back up. which is typical of Nest cameras. When they take a power hit, it's kind of random whether they come up or not. But so we noticed that that one didn't come back up, but we got power back online. So shout out to Southeast Colorado Power for supporting us. This was right during the Super Bowl. I'm sure they would have rather been watching the Super Bowl, and it's a long drive from their service location to where we're at. So we appreciate what they did.
Do we know what happened?
Nope.
Okay.
Probably another bird on the wires. We had that happen one time. We were out there and one of the pigeons landed on the transformer out at the pole and the line to neutral, and that was killed the bird and put our power out. But Southeast Colorado Power came right out and fixed it within a couple of hours.
And that would be some good information to have posted down there also at the operator desk of our account number and their phone number in case there ever is an issue while we're trying to accomplish something.
Yep.
So we're not dependent on who knows that information.
That's right. Yep. Yeah, that's true.
We have that.
Need to do that.
We have a backup generator, at least a generator. I couldn't say it's backup, but there's a generator that's right now in the garage. Is it possible to use that generator as a backup for at least the internet system in our building?
Yeah, you'd have to plug everything over. We don't have a transfer switch or any way to tie it into the building. What we really need is a transfer switch that you could put the thing on there and just pull it over. Go ahead, Myron. Yeah, go ahead, Myron.
The generator has a 220 30 amp outlet, 240, and a 20 amp 120 outlets. That generator hasn't been started in about 3 months. So maybe it might be a good idea for somebody down there this coming weekend to start it and let it run for a while. When you start it, put a heater on one of those heaters for a load and run it under load for about 30 minutes, then gas it back up and put it back in the garage. I got that generator. I bought it and basically loaned it to DSES for the time being. So in case the power went out and the dish was tilted, we could put the dish back in the stowed position. And we initially ran that dish off a 3,000 watt generator for many months until we got a little more permanent power. So it will put the dish in the stowed position if necessary. But I don't think anybody could do that, not from being familiar with the hookup of the AC power to it. What do you think, Bill?
Yeah, that's going to be tricky because we have no way to really get off of the electric utility line onto the generator without a transfer switch. And so that's something we might want to look into for the future, because you do make a good point that if we lose power and the dish is tipped over, we have to get the dish back into bird bath position to stow it before leaving the site. And if there's wind, we definitely have to get it there. So before that was easy to do because we had just a plug that we could plug it in, but we don't have that now, and any kind of plug on it would have to have a safety transfer switch.
Yeah, we don't want to backfeed the lines.
Nope.
Okay. Is there
but at least run the generator to get some time on it.
Yeah, that's a good point. Generators tend to collect moisture in the fuel tank when it's cold and hot. And
I did put stable in the fuel tank after I ran last time I ran it. So it's that fuel additive called stable. So that's in the fuel tank. So I think there's some more of that out there, but it definitely needs to be run again. I was going to do it when I was down there 2 weeks ago. I just didn't have time to get there to do that.
Is there gasoline in the container there?
There is gasoline down there somewhere. It might be on the pedestal. I did not want to store it in the garage, so it may be in the pedestal.
I'll take a look when I'm down there this weekend. Very good, guys.
Do you want to mention the nominations are still open for anyone?
Oh yeah, that's good point. Yeah, I was hoping Bill Thomas would be on here, but I know he's tied up. Yeah, so the nominations, I believe, they will end on Wednesday, this next week, and
this coming week or next week?
This week.
Like tomorrow? Like tomorrow, Wednesday?
No,
Or
day after
Thursday?
tomorrow.
Day after tomorrow, okay.
Yeah, and then we'll announce the those who are up
So
for election. Hmm?
do you have a list of those being nominated now? Or can you say that, or?
I'm not sure if I can say it or not. I'd have to have the bylaws in front of me to do it. I'm not sure yet, but we'll definitely do that probably at Wednesday or the day after. Bill Thomas is going to do that. So,
Can you put it on Groups.io?
yeah, well, Groups IO and directly to all the members. We have that Ham Ham Club Online program that has everybody's information, email. There's a few members that are not on that, and they can get it from the group IO. Okay. And thank you very much, everybody, for spending some time with us this afternoon or this evening. And we're looking forward to an exciting adventure there with the Artemis program. So thanks again for everybody coming on board.
Thank you. Have a good night.
Yeah, good night.
Good.
Have a great one.
Night, guys.